Hello, so let's start with this Newton's method. This is chapter 4, section point 8. Uh, this is a method Newton found out a technique to find the real number solution to an equation if x equals 0. These solutions, as you know, the real number solution or the zeros or the x-intercepts are kind of the same thing. Finding the zeros of a quadratic equation or linear equation is easy, but when you have a little more complex equation, let's say a polynomial of higher degrees or trig functions or uh, the the equation involving radicals, then uh, then it's a little tougher to find the zeros of the equation. Newton's method uses tangent lines to zero in on a zero. So here it is, like if you have a graph, okay, on the graph you have to make an initial guess. So let's say this is an initial guess of x1. Okay, at x1 you draw a tangent line. Okay, and this is let's say this is a zoomed in graph. As we see, this x3 is the real zero. It's pretty close to the zero of the graph. We start making a guess first. Let's say this x1 is the real zero. At x1 we draw a tangent line wherever that intersects the x-axis. We draw a perpendicular line there touching the graph. The new point, that's what we name it as the x2, the x coordinate of that point. When I say x1 or x2, x3, I'm talking about the x coordinates of those points. At x2, again you draw the tangent line. You see that this portion is black, so that's a tangent line. Now, as you keep repeating that process, you keep getting closer and closer to the real zero. So we are kind of zeroing in to the real zero of the function. And let's say how it's done. You start with a guess, x1, then the tangent line at the point here will be x1 and f of x1. The y coordinate is fx. This will have a slope of the derivative of the function at x1. Now let x2, 0 be the point where the tangent line crosses the x-axis. Okay, so this is x2, 0 because it's on the x-axis. Then the slope of this line, of this tangent line, okay, which is derivative of the x1, derivative of the function at x1, we can write it as 0 minus f of x1 over x2 minus x1. The slope is the derivative, and also it is the formula for the slope is y2 minus y1 over x2 minus x1. In this case, y2 is 0. So 0 minus f of x1 over x2 minus x1. And when we solve this for x2, we get this function x2 equal x1 minus fx1 over f dash of x1. So this is our next point closer to the zero. And when we repeat that, the same process, when we draw the tangent again, we will get x3. We will do the same process. So we will get x3 equal x2 minus f of x2 over the derivative of the function at x2. So after some iterations, then it will converge to the real zero, the actual zero of the function. It's like that you're shampooing your hair. You lather, you rinse, then you repeat until the water runs clear. So here it is. That's after a number of iterations, the xi will converge on the actual zero of the function. So we generalize the formula as this: x of n plus 1, the next guess or the next point closer to the zero will be equal to the previous guess minus the function value at the previous x over the derivative of the function at the previous x value. So you don't have to really go through the whole calculation again and again and again until you reach the actual value. Your calculator does most of the work for you. Important thing here is to find the derivative of the function. All right, so let's take an example, and I'm going to show you how to enter those things on your calculator, how you use your graphing calculator to your TI-83 or 84 would work fine. If you have another graphing calculators like the Casio one, you might have different key sets. So let's take an example here. Let's say you have to find a zero of this function, that is x to 5 plus x minus 1 near x equal 1. Now this x equal 1, this is your initial guess. This is your x1 value. x2 value will need this x1. Okay. So what you do, you have to enter fx and f dash x as y1 and y2 respectively. So you go to the y equal key on your calculator and enter this function and this function. The derivative of this will be 5x to 4th plus 1. So enter that as y2 and enter the function as y1. Next, because you want to find a zero near x equal 1, so these are the things to know. You want to find a zero near x1, so store the initial guess x1 equal 1. How you do that? You press 1, then you press the store key, that's just above the on key on your calculator, and then you press alpha x and hit enter. So your initial x1 is stored as 1. You have assigned the value 1 to the variable x. Now you have to enter the formula. This is the formula: xn plus 1 xn plus 1 equal xn minus f of x n over f dash of xn. So we don't have to enter the xn plus 1. It will be like that. So after hitting that, you have to enter this formula: x minus y1 over y2. Now where this y1 and y2 coming from? That's from the function. So you have to enter this y1 and y2, you have to hit the vars key on your calculator, then select the y vars, then select the functions, and then select y1 to enter y1. And then you say divided by this slash, so y1 over, and then the same key set, but here you select y2, then again you hit store key and alpha x and hit enter. You will get this value. Now do you have to repeat the same hit? You don't have to enter this formula again and again. After you get this number, you already have and stored this as your new x, and now you just press enter again and you will get a new number here. Okay, so you have to continue pressing enter until the numbers reach a limit. Usually the question asks you to find it to 8 digits after decimal, or 6 digits. So you keep entering hitting the enter, and when they start matching, you see these values, then you stop. Then you say that okay, so 0.7548776662 is a zero of the function this. Okay, now this was a polynomial. The same thing you are going to do with this cosine x minus x cube near x equal 1. Again, your x equal 1, that means your initial guess, and you say that cosine x minus x cube, you store that as your y1. The derivative of cosine x minus x cube will be negative sine x minus 3x square. So you enter those y1 and y2 on your calculator, and again the same set of keys. You say 1 store alpha x, to enter 1 as your x, and then you enter this formula and you keep hitting enter unless you start getting the same number. But sometimes this Newton's method fail to work. Sometimes you don't get the desired result. When would that happen? It happens when your guess is the critical value, let's say, because you see if a critical value of fx enters the sequence, then you cannot find it. Why? Because at critical value, the derivative of the function is either 0 or undefined. Then if this is undefined, this whole thing becomes 0. Okay, if any number divided by undefined or infinity is 0, so xn plus 1 will become xn, and there is no, and then you keep getting back to xn, so you won't converge to the desired you won't get the desired result, though you can't zero in on the 0. Now if you have xn f dash xn undefined, sorry, now if it is 0, then this becomes undefined. Your xn plus 1 will be undefined. And sometimes in some oddball cases, when the function is not smooth, the sequence of approximation won't converge on a limit. Let's see an example. Okay, try this example at home. X cube minus 2x minus 2 near x equals 0, and whatever result you get, and you know what keys you need to enter. This x cube minus 2x minus 2, this will be your y1, y2 will be the derivative of that. Your initial guess is 0.